Okay, this is Solving Radical Equations Part 2. So we're going to talk about some slightly more complicated examples of radical equations. So in C, usually our first step is to isolate a radical on each side, or our radical on one side. In this case, we do have a radical on each side that's isolated. So we're going to go right to step 2 and square both sides. When we do that, we get 5x plus 1 equals 3x plus 8. And now we need to do some algebra. So let's subtract 3x from both sides. So we get 2x plus 1 equals 8. And then let's subtract 1 from each side. So 2x equals 7. And finally, divide both sides by 2. So x equals 7 halves. Okay, so again, we squared both sides. We subtracted 3x from both sides, subtracted 1 from both sides, and then divided both sides by 2. Don't forget to state your restrictions, okay? So we actually are going to have two restrictions. So 5x plus 1 has to be greater than or equal to 0, and 3x plus 8 has to be greater than or equal to 0. So for this one, we have 5x is greater than or equal to negative 1, so x has to be bigger than or equal to negative 1/5. In this one, we have 3x is greater than or equal to negative 8, so x must be greater than or equal to negative 8/3. Now, which restriction do we follow? Because negative 1/5 is larger or more positive, it's closer to 0, than this one, we are going to choose this as our restriction, because this will include negative 8/3. Because it's saying x has to be bigger than or equal to negative 1/5. Well, negative 8/3 is definitely smaller. It's on the right side. So this is our restriction. Thanks.
Thanks, Gil. We'll be here at 12:15.
Okay, sounds awesome.
Or you can text us.
Okay. Okay, and so now you just have to check your solutions. Okay, so if we check our solutions, left-hand side, right-hand side, the square root of 5 times 7 over 2 plus 1 should equal the square root of 3 times 7 over 2 plus 8. So we have the square root of 35 over 2 plus 2 over 2, and I'm changing this 1 to a 2 over 2 because I want to add like fractions. Or sorry, common denominator fractions. And this one on the right hand side would be 21 over 2 plus 16 over 8, 2. 16 over 2. Okay, so we have 37 over 2 square root equals the square root of 37 over 2, so our answer is correct. Now, sometimes, like in example D, you'll have square roots on both sides, and so we have to move stuff around. So let's start by adding 5 root 2x to both sides. So we have 4 equals 8, well, negative 3 root 2x plus 5 root 2x is 2 root 2x, and then we can subtract 8 from both sides. So we have negative 4 equals 2 root 2x. Divide both sides by 2, so negative 2 equals root 2x. This is all step 1. And now we are going to square each side. So 4 equals 2x, so x equals 2. We have our solution. Again, let's talk about restrictions. In this case, we just have the square root of 2x, so x has to be greater than or equal to 0. This one should be fairly straightforward because we just have to ask what can we plug in for x that will make it negative, and it's any negative number. So x has to be greater than or equal to 0. And then we're just going to check. So left-hand side, right-hand side. So 4 take away 5 times 2 times 2 should equal 8 take away 3 times 2 times 2. So let's see, 4 take away 5 root 4 is equal to 4 take away 5 times 2, which is negative 10. So this side equals negative 6. On this side we have 8 take away 3 root 4. So we have 8 take away 3 times 2, which is 8 take away 6, which is 2. Now notice, these do not equal each other. So we would say that x equals 2 is extraneous. We cross our answer out. You must either write it is extraneous or cross the answer out. Our last example, we also have 2 square roots, but there's no way of getting them both isolated. Because of this 3, we can move it to the other side, but then that side wouldn't be isolated. So we're actually going to have to do steps 1 and 2 twice. Okay. Okay, so let's just go ahead and skip step 1 and we're going to go to step 2. So step 2, we're going to go ahead and square both sides. And again, we can't do step 1 because there's no way to isolate both of these radicals. So we're going to square both sides and we get x plus 2 on this side. And remember, when we square a binomial, we are multiplying it by itself. So we have 3 times square root x plus 7 times 3 minus square root x plus 7. And if we simplify, 3 times 3 is 9. 3 times root x plus 7 is minus 3 root x plus 7. Negative root x plus 7 times 3 is negative 3 root x plus 7. And finally we have negative root x plus 7 times negative root x plus 7, which is positive x plus 7. The radical goes away because a root times a root of the same terms underneath gets rid of the root. Again, we have to simplify. So we have 9 take away 6 root x plus 7 plus x plus 7. So now let's do a little bit of algebra before we square again. So let's subtract x from both sides. So we get, and let's actually subtract 9 and subtract 7 from both sides. Okay, so we've canceled that, we cancel that, and we cancel that. So we can say that we have x minus x is 0. 2 take away 9 take away 7 would be negative 14 equals negative 6 root x plus 7. Okay, so again, I subtracted x from both sides, and that eliminated this x. And then I also subtracted 7 and subtracted 9 so we could get this radical entirely by itself. So now we can divide both sides by negative 6. So I get 14 over 6 equals root x plus 7. And I can go ahead and square this again so I get rid of the final radical. Because now I've isolated the radical by itself. So 14 over 6, we have to figure out what 14 squared is. And x plus 7 just becomes x plus 7. So 196 over 36. So 196 over 36 plus, take away 7 equals x. And I'm going to leave it up to you to figure out how to combine these and then check your answer. Now before you do that, let's talk about the restrictions. So this is step 3 and this is step 4. So the restrictions, we have square root x plus 7 and square root x plus 2. Those are our two things. So in this one, x has to be greater than or equal to negative 7, and in this radical, it has to be greater than or equal to negative 2. So because this is the larger one, this is our restriction. So all you need to do is check your answer.